The Ferensola Gold Project is located in northeast Sierra Leone, approximately 200 kilometres east-northeast of the capital Freetown. The licence, registered under Sula's 100% owned subsidiary Blue Horizon, totals 153 kilometres squared and is host to the Ferensola Iron Project and the recently announced Ferensola Gold Project. The licence is located within the highly prospective Sula Greenstone Belt, with the Ferensola Iron Project being contiguous to the Tonkalili Iron Ore Project, which is owned and operated by Shandong Steel. The Blue Horizon licence is host to extensive major artisanal workings that have been exploited for decades, with the Blue Horizon field camp located within a few hundred metres of the locally named Q8 artisanal area, which is host to over 1,000 hand-dug pits. Historically, the area has undergone extensive exploration by previous owners, with soil sampling showing the presence of regional-scale anomalies. Additionally, the area was drilled through RAB and diamond methods, with two of the areas covered by diamond drilling shown here. As shown, the drilling in the southern of the two areas was drilled to the west-northwest at 50 degrees dip, and in the northern target close to the field camp, all holes with the exception of one, SDD-033, was also drilled to the west-northwest. The diamond drilling was partially successful in that three of the northern target holes intersected high-grade gold mineralisation, including hole SDD-033 being the numerical penultimate hole. These intersections are on adjacent drill lines, being approximately 150 metres apart. Grades reported from the northern target drilling included 8.7 metres at 10.5 grams per tonne and 9 metres at 6.6 grams per tonne. In the southern of the two targets shown, a single intersection was reported of 6.4 metres at 1.72 grams per tonne. It is important to put the historical drill orientation in the context of the regional geology. Modelling of the Ferensola Iron Project shows a general dip of approximately 60 degrees to the northwest, meaning that the historical drilling, should the regional trends of the geology continue to the northeast, is orientated sub-parallel to the regional grain of the Sula Greenstone Belt and potentially suboptimal in terms of the gold exploration carried out. Since Sula acquired the licence, gold exploration activities have included detailed ground magnetic geophysical surveys, soil sampling with partial XRF analysis, and more recently, 5 trenches were completed across selected targets, including 2 in close proximity to the northern area close to the Blue Horizon camp and historical drilling undertaken. A summary of the pre-June 2015 studies resulted in a series of anomalous gold values that are coincident with the general trend of the ground magnetic data and indicated the potential for significant and extensive gold mineralisation. Significant results have been recorded from the historical RAB and diamond drilling, soil sampling and recent trenching. Also of note is the location of a soil sample that returned a grade of 54.4 grams per tonne. In June 2015, after Sula personnel had compiled and reviewed all available data for the Ferensola Gold Project, a site visit was undertaken by Mr. Howard Baker of Sula and Dr. Chris Bonson, Principal Structural Geologist of SRK Consulting UK Limited. The aim of the site visit was to review the geological aspects of the project and independently resample the recently completed trenches and the key intersections from the historic diamond drill programmes. Ultimately, the aim of the visit was to determine the likely geological orogenesis model to aid future exploration plans. In this respect, the work completed was hugely successful and the true potential of the Ferensola Gold Project became increasingly evident. On inspection of the trenches, numerous key observations were made. Firstly, it became clear that the area under study is covered with a hard jewellery crust or iron cap, and that the mechanical excavation of the trenches was difficult. Secondly, it was observed that in all cases where gold grades had been reported, it was clear that the mineralisation was associated with iron oxide nodules of hematite and goethite, and that these formed discontinuous zones across discrete areas of the trenches. It was unclear if the nodules were close to their original in situ location, and it was not possible to record accurate structural measurements. From an exploration perspective, the trenches highlight the difficulties of exploration in terrain with a hard jewellery crust cover, and significantly, it highlights that the soil sampling programs completed, whereby shallow soil or rock chip samples are collected from surface, are likely to have a low success rate due to the nature of the mineralisation being restricted to narrow gold-bearing nodular fragments. That said, the trenches clearly show that the gold-bearing lithologies do have a surface expression, and the nature of the host material is likely to be associated with iron oxides. Trenches 2, 5 and 11 were independently resampled under the supervision of Howard Baker of Sula. All new assays were averaged with the original unsupervised sampling results to determine the reportable results. In the historical northern drill target area, Trench 2 returned combined assay results of 2.3 grams per tonne over a 20 metre zone, including 4 metres at 3.4 grams per tonne and 8 metres at 4 grams per tonne. Trench 5 returned combined assay results of 1 gram per tonne over 24 metres, including 4 metres at 1.3 grams per tonne and 4 metres at 3.9 grams per tonne. Trench 11 in the southern historical drill target area returned 4 metres at 3.28 grams per tonne and 4 metres at 2.54 grams per tonne. Due to the limited outcrop within the licence, river traverses were undertaken in an attempt to locate additional mineralised samples. Of note was a location lying just south of trench number 5, being 400 metres from the Blue Horizon camp and just north of the Q8 artisanal field. From this location, samples of artisanal goldstones and partially weathered sulphide stones were located. The goldstones represent material targeted by the artisanal miners, being similar to the iron oxide-rich nodules observed in the trenches. The sulphide stones are believed to represent partially weathered derivatives of the underlying primary ore, with the goldstones representing the fully weathered derivative. The goldstones are targeted by the artisanal miners due to the fact that all gold has been liberated from the degraded sulphides, being predominantly pyrite, as observed in the sulphide stones. It is worth commenting that it is believed that the samples located represent near-source samples, as they were recovered from dumps surrounding the artisanal pits in this area. In total, 8 near-source goldstone samples were submitted for assay, with an average returned grade of 5 grams per tonne, with a minimum returned grade of 0.2 grams per tonne and a maximum of 12.4 grams per tonne. 2 sulphide stones were submitted for assay, returning grades of 7.5 grams per tonne and 4.2 grams per tonne. This video shows the locations of the goldstones and sulphide stones in relation to the ground magnetic data and the topographic features. The goldstones are shown in red and light blue, and the sulphide stones are shown in dark blue. The location clearly highlights the southern extension of the mineralisation from the historic drilling. In addition to the goldstones and sulphide stones recovered from this location, a sample of major significance was also recovered. The partially weathered pyrite-dominant massive sulphide sample shows clear folding, with sulphides being present, along with quartz tourmaline vein material. Common fold fabrics are observed within the sulphides and the host lithology, suggesting that sulphide mineralisation took place before or during the folding event. The folding observed is considered significant as it possibly represents classic saddle reef gold traps that can be related to major high-grade gold deposits. This sample, along with the other evidence observed and recorded, has helped advance the understanding of the Ferensola project enormously and plays an important role in the exploration strategy going forward. The significance of this sample in relation to the project as a whole is discussed further within this presentation. This sample has not been assayed due to its geological significance. One of the key objectives of the June site visit was to relog and resample the historic drill core. This was undertaken by Dr. Chris Bonson of SRK. In addition to gaining confidence in the historic grades reported, it was important to assess the appropriateness of the historical drilling in terms of drilling orientation and dip in relation to the possible orientation of the mineralised zones. The resampling was very successful, with 15 samples taken from hole SDD-004, SDD-016 and SDD-033. SDD-004 returned 19.5 metres grading 9.2 grams per tonne. This included 6.1 metres at 14.8 grams per tonne and 5 metres at 17.4 grams per tonne. SDD-016 returned 4.3 metres at 5.2 grams per tonne, including 0.5 metres at 21 grams per tonne, and SDD-033 returned 5.3 metres grading 3.4 grams per tonne, including 1.1 metre at 12.3 grams per tonne. A further significant observation made was that the mineralised zones show a strong magnetite alteration. Magnetite is a highly magnetic iron oxide that upon weathering converts to the iron oxides hematite and goethite. It is therefore concluded that the hematite and goethite observed in connection with the superficial goldstones is a direct result of the weathering of the primary ore. In addition, it is concluded that the magnetic anomaly observed from the ground magnetics is a result of the magnetic alteration connected with the primary ore zones. The confirmation of the historic grade was a significant boost to the project. However, of possibly greater significance was the conclusion that the historic drilling appears to have been carried out sub-parallel to the mineralisation. The following images are taken from the SRK report made available through the Sula website. The images show fabrics recorded from the drill core and highlight that those holes drilled to the west show an observed fabric with a low intersection angle, and those drilled to the east, being the single hole SDD-033, show an intersection angle more perpendicular to the drill core. It was therefore concluded by SRK that a conjectured northwest dipping mineralised structure could exist, highlighting the suboptimal orientation of the west inclined drill holes. Of the 34 drill holes completed, 33 or 97% were drilled to the west, and this may explain the lack of successful drilling, particularly in the northern target. When translating this knowledge to the project, focusing on the northern historic drill target and utilising all data collected to date, this being the RAB and diamond drill assays, the Sula trench results, the Sula goldstone and sulphide stone samples, and the Sula ground magnetic anomaly data, now believed to be a result of the magnetite alteration, it is possible to generate potential northwest dipping planes of mineralisation that only intersect the historic drill holes with high-grade gold reported. Whilst being conceptual in nature, the proposed interpretation, being formed of multiple planes of mineralisation, fits the existing data. On a regional scale, a large fold structure has been identified with a trace length in excess of 10 kilometres and where multiple high-grade targets are located. Shown here by the black dashed line, the fold closes to the northeast and exhibits multiple parasitic folds along its entire length, with the main fold axial plane trending northeast-southwest. Sula has collected assay data from multiple points along the fold structure, which strongly supports the interpretation. To the south, Trench 11 and historic drill hole number 13, as shown here, are located within a possible fold hinge. It is noted that Trench 11 was excavated parallel with the fold hinge rather than perpendicular, which would have been the optimum orientation. Moving north, recently submitted soil samples from a previous sampling campaign show anomalous grade, including one sample grading 5.7 grams per tonne. In addition, recently located goldstone samples, shown as green dots, support the extension of the parasitic fold to the northeast. Continuing north, and as discussed previously, multiple assay results support the interpretation in the northern historic drill target area. Additionally, during the June site visit, goldstones were observed being mined by artisanal miners from a narrow creek, again shown here by the green dot. Moving to the west of the actual plane, additional fold hinge targets are identified from the magnetic anomaly and is supported by the location of the Yan Ferran artisanal mining area and the close proximity to the 54.4 gram per tonne sample. Of striking significance when put in the context of the regional fold interpretation is the location of the large-scale artisanal mines in the area. These are located clearly truncating the full width of the fold structure and, equally importantly, are close to the potential fold hinges associated with the parasitic folds. From the work completed, it is now clear that the gold being mined by the artisanal miners is related to the high-grade mineralisation identified and previously described. As previously discussed, the recent interpretation of the regional structures and controls on mineralisation are supported by the work undertaken by Sula and SRK Consulting. Of key note is the evidence gained from the folded massive sulphide sample, which clearly forms a relic of the weathered fresh massive sulphide and quartz tourmaline veining observed in the drill core. The folded nature of the sample and the fabrics observed support the theory of fold hinge mineralisation, with the sample being located in an area of folding supported by the ground magnetic data. The genetic model currently postulated by Sula relates to fold-hosted gold mineralisation where hinge regions control the ore shoots. It is further postulated that the mineralisation is related to shear zones associated with the folding event and that the gold mineralisation phase occurred before or during the folding event. In July 2015, Sula announced the generation of a JORC-compliant exploration target for the Ferensola project, authored by SRK Consulting UK Limited. The exploration target covers a 2-kilometre portion of the fold belt with evidence for high-grade mineralisation over a distance in excess of 10 kilometres. The exploration target is located in the region of the Northern Historic Drill Target, where sufficient data was available to generate the exploration target. In defining the exploration target, SRK used the magnetic anomaly to define a fold structure and to establish a trace length for the mineralisation which approximated to 2 kilometres and with a dip extent of 300 metres. Mineralisation is assumed to comprise of discontinuous sheets of massive sulphide of between 2 and 5 metres in width, with nominal strike extents of between 100 and 300 metres. The most significant accumulation of mineralisation are assumed to be contained in fold-hosted shoots akin to saddle reefs. SRK defined an exploration target for the Ferensola project with a tonnage range of between 5 and 7 million tonnes at a grade range of between 4 and 8 grams per tonne. This equates to between 0.8 and 1.5 million ounces of contained gold. To conclude, the reinterpretation and validation sampling undertaken by Sula and SRK has begun to unlock the true potential of the Ferensola Gold Project, with Sula believing that the project is potentially larger and regionally more significant than previously recognised. The sampling undertaken has confirmed the high-grade potential of the project, with the current exploration target covering only 2 kilometres of a mineralised belt that is potentially in excess of 10 kilometres. With increasing confidence in the geological interpretation, Sula has identified initial drill targets and will commence a scout drilling campaign in November 2015. Initial drill holes, drilled in an easterly direction, will target the historical intersections with detailed structural logging being employed on each hole to provide greater confidence in the siting of the subsequent step-out holes.